Water is obviously a very important molecule when we start talking about living organisms. And just for a quick review, water is H2O, as I think you already know, and when we look at the structural formula of water, this is what we have. So we've got oxygen, and then it's separately bonded to two hydrogen atoms, and specifically we can call those bonds, both of them, are going to be polar covalent bonds. And this is really an important aspect here because this is going to be responsible for a lot of the unique properties that water molecules have. So if we talk about those bonds a little bit more, they are polar covalent bonds because the oxygen is very strong when we talk about its electronegativity, and the hydrogens are both very weak. So they don't have a lot of force to pull on surrounding electrons. So if these are covalent bonds, we're sharing electrons, but if the oxygen is so strong, that means the electrons are going to get pulled much closer towards the oxygen end of things. And this surrounds that oxygen atom with a lot of extra electrons, and that means that the oxygen is going to have extra negative around it. So that end of the water molecule will have a negative charge to it. And then on the other end of things, the hydrogens have had their electrons kind of shifted away from them, and that's going to leave them a little bit short on negative charges, or in other words, they're going to be a little bit positive. So we end up with this molecule that has a negative end to it, and then it has positive ends to it. And if we just look at that another way, a lot of times if we're drawing water molecules really quickly, we just draw little V's here. And when we do that, water is a bent molecule. The pointed end here, that would be that negative oxygen end, and then the other two sides, that would be where the little hydrogens are at and where we have the positive charge. Now, water's properties, when we start talking about the properties of water, a lot of those properties are due to the fact that we have these two opposite sides and opposites attract. And when we say opposites attract, what we're really referring to is the fact that opposite charges attract. So whenever you have something that has a positive charge, it will be attracted to something that's negatively charged, and vice versa. So if we talk about how water molecules interact with each other, just for example, the water molecules, if you have multiple ones of them, they can be oriented kind of like this. And I'm drawing these in a way that the positives and the negatives are going to be next to each other. So if we look at this, remember that all the pointed ends would be negative ends, and then the other ends are your positives. And I've drawn this so that it's always a positive next to a negative. And when we have it, they can be attracted to each other. So these little dotted lines, they're representing an attraction. And so notice that all these water molecules are going to be somewhat connected together by these little attractions that they have of those opposite charges. And that's what is responsible for a lot of the properties that you see in nature, like surface tension, the fact that leaves can float on the surface of water. They can float because those water molecules are not all completely separate from each other. They're kind of tied together by this attraction between them.